Hi, welcome to Selectmen's Roundtable. I'm John LeBeau, and with me are three of my fellow selectmen, Morris DiPaolo, Beth Cassavant, Moira Miller. Jim Kane couldn't join us tonight. Also with us is Town Manager Kevin Mizigar and Superintendent of Sewer and Water. Is that correct?
That's correct.
I got it right. Bob Tzeski. And we are at our brand new treatment plant. Providing treatment to Shrewsbury water, and we're going to do a little video tour in a bit, but we thought first we'd talk about this facility, the need for the facility, and exactly we have new, brand spanking new technology that we're using here. So Bob, could you give us a little overview?
Sure. For a number of years, the town had some issues with manganese, which is a groundwater mineral. And as most water sources in New England, which are groundwater supplies, you're either going to have iron or manganese or a combination of the two. Fortunately, in Shrewsbury, you have very low iron but high manganese. And from the years 2010, 2011 up to 2016 were pretty much drought years. 4 or 5 of those years were drought years. So around 15 and 16, the water tables got significantly down, manganese levels went significantly up in 2 of our main wells, and then a third one a little bit later on, and causing quite a bit of, angst about from our customers because of the manganese over there. And because of that, we met with the Selectmen and we met with other folks in town to look at what the solution was. Traditional solution for these things is usually some type of green sand filtration, which is a chemical precipitate where you precipitate out the manganese and it's removed off-site down there. However, when we pilot tested it, we looked at a third method, a biological method that's used primarily in Europe, in France, Germany. It's also used in Australia, New Zealand, but only limited here in North America over there. So when we piloted that, we found this was far superior over there. Longer filter times, better results for the town, less chemical usage, especially potassium permanganate for the folks, and we felt that this was a better long-term investment for the town of Shrewsbury and for the residents going forward to have this type of treatment like that. So we started in July of 2017, so just a year later on, we brought the first flow in September of this year, 2018, and we went fully online about mid-October of 2018. So it's been on about 6 weeks now. Basically, our results are very good upon that. We're basically getting 0 manganese out into the system. Checkpoints, comprehensive points out there also confirm that it's basically at 0 out into the system out there. You know, obviously there's buildup on the pipes from some years over there. It's going to take some time to work out, but the most important thing is to try to get the source, work our way out on that down there, and we are hoping to have better and better results for our customers going forward between the treatment plant, flushing programs, and other comprehensive methodology on our system there.
Is there sort of a simple way to briefly explain how the biological agents work? I mean, how that
Sure.
clears that out of the water?
Sure. In biologic, I probably should have said, is what's known as it's a green technology. It's a sustainable technology compared to green sand filtration. And it's the way going forward that I see and other people see in the water treatment business here and throughout the world over there. Because basically the manganese and also iron contain bacteria, non-pathogenic bacteria, that depend on small amounts of oxygen for their growth and existence in the pipes over there. So basically, as the water comes into these filters, we have 5 foot of sand, polished sand that goes through. And as the manganese goes through, we control the growth factors, we control the dissolved oxygen, we control the pH, and it creates a little bit of a sheath and sheen on the sand that attracts the manganese on there, and it holds onto the sand. And as it works its way down, there's 520 nozzles in each one of the filters that further take everything down very gradually there. So we keep running that through and running that through. And then once the differential pressure builds up, the mass builds up like that, we backwash the filter, and then after 4 hours we take some of those solids and we pump them back again to the beginning of the filter, so you always have a solid mass and growth on that down there. But once you get the growth going, it's a very sustainable type of technology, because you can even have it off, once it's all grown, for about 7 days, and not have to even worry about it. That was one of the questions that we have, is if the plant shuts down, you don't have a water source, are they gonna die off? Once they're established, they should last 7+ days. For us right now, they're still in a fragile state. They were about 18 inches down in the 5-foot bed right now. So we're looking about mid-January to hopefully get everything down to about the 5 feet down there. We're going to do some flushing and some other cleaning this fall, but between us and the process engineer, we said, you know, let's build up the mass. It's still somewhat fragile. Let's let the water itself work its way through, try to loosen up the material, the manganese that's in the pipes, and we'll have better results in April and May trying to get through. Because it does take a lot of water to flush, and a very efficient way to do it would be to wait for this and then come back in the spring rather than the fall to do that there. So, and we're very happy with the results right now, and we're very excited actually, you know. The budget right now is, we basically had no change orders on this project down there, $12 million project down there. So we have substantial completion right now. They've torn down the old building. We're going to be doing some solar panels, 60 kW solar panels in the spring. That will help power up the plant, and we're leaving provisions for a second panels. If someone in the future sees fit to do that, you'll have a second array that you can put on over there. So we're using green sustainable technology. We're using further technology, solar, to help us out over there. And if you see through the building, we have a lot of sensors. We control all the humidity to about 30% in the building. All the high efficiency lights, motors, aerators are all high efficiency down there. We use less energy in there. And so we have a very sustainable building, and we have an east-west orientation so we can pick up the southern light with translucent panels in the filter room over there, which you probably couldn't notice at night as you come in. That helps control our energy costs also here. So everything's about energy costs and getting good quality water out to our customers, because, you know, even though it's an aesthetic problem, it also impacts people's lives and lifestyles when you're having manganese come into the house and laundry issues and so on and so forth down there. So we want to get by that. But this is step one. Control it at the source, work our way through the system, and get progressively better water to our customers.
Now, in addition to the pilot study and the various filtration options or treatment options, we also did some financial modeling and studying when we were thinking about which path to take.
Yeah.
And we looked at several different options, including essentially, when I say getting out of the business, it didn't mean that the water would no longer be treated, but we even looked at possibly like joining the MWRA, I think,
Yep.
or I can't remember how far we looked into the.
We looked at it extensively. We looked at the city of Worcester. We looked at MWRA two ways. One from the Caro plant in Marlboro, running it through Northborough, coming this way, but we'd have to reverse the entire system. From here we go out, we'd have to get the system coming in from the Ward Hill side over there. Major project to do that, and a significant buy-in fee to the MWRA also. We also looked to take the raw water from Boylston, come out Route 70, come this way, and treat it, do another treatment facility up just from this plant out there. But there was some issues with MWRA also there. And we looked at City of Worcester, which we do have a 12-inch connection on Route 20 for right now. But if you notice in 2016, even Worcester had problems themselves with water. They had to buy in MWRA there. We felt this was the best option, the most sustainable option for right now, to control our own destiny, so to speak.
Now, should our customers during this period that we're moving, well, we've moved from the old treatment to the new.
Yes.
Should our customers, our users, expect any differences in their water, or are you hearing?
Well, yes. I mean, there are some differences. We've changed somewhat of the chemistry going through there. We had gaseous chlorine and chlorine gas. We switched to sodium hypochlorite, 12.5%, which is a liquid form. We've changed from the hydrofluorosilicic acid, which is a liquid fluoride, over to sodium fluoride, which is a powder. And the main reason for both of those is safety. Chlorine gas is very hazardous, especially for the operators working with them. Chlorine's 2.5 times the weight of air, so as it stays down to the ground and the cloud just goes out. And it's a poisonous gas, respiratory issues with that. Hydrofluorosilicic acid of a pH of 2 etches glass. plastic, again, respiratory problems. So we've gone to the safer modes on that down there. Now, obviously, as the water goes through the system, we've changed the chemistry. So as that manganese is on the pipe, it's going to start sloughing off from time to time. So customers could periodically encounter some discolored water on that. As the chemistry changes, the manganese that's no longer coming out is not supporting the chemistry that's inside the pipe that's being changed. So that's going to kind of diminish, and then eventually slough off. So you can get some discolored water and some other issues from time to time. But that's the progression that we see up on that there.
We just got a couple minutes before I think we're gonna do a video tour. How many people work here, and how has it changed to how many people worked at the
That's
other
the
building?
same amount. We have one main operator, and we also have Rich Fox that is our assistant down here. We just man it during the days. The rest is all automatic on SCADA controls, which I can show you later on there. It's all automated that we do this over there. Filters are in semi-automatic, but everything else is in automatic mode over there for alarms, functioning, and functionality.
Okay.
Makes me wish I paid attention to chemistry class.
Yeah, I know. Yeah.
I'll remind you all.
Okay, well, I think we may get a little chemistry class now.
Yeah.
So I think we're going to stop tape, as they say, and then we're going to take a tour of the facility.
We're down in the pipe galley of the new water treatment plant. Flow is coming in this 16-inch ductile iron line right here. We adjust the pH by means of potassium hydroxide at this point right here. As the flow comes in, it comes in to what's known as a static mixer right here. We put oxygen in here, fine bubbles, mixes in here, and goes upstairs to the filter system. We're in the filter room now of the water treatment plant. We have 4 pressure filters, pressure filter 1, 2, 3, and 4. These are the biological filters that control the manganese in the system. The finished water comes up, goes up to the top of these filters, goes through a 5-foot bed of sand, percolates through, adheres to the sand, then goes to a series of nozzles out the bottom, back out to the back room and out to the filters and for aeration. Once we get to a certain pressure or usage, backwash is initiated, where flow comes out of the top, back down, and over to these 2 decant tanks back on this side here. Once the tanks are backwashed, they go into either decant tank number 1 or number 2, where they sit for 240 minutes or 4 hours. After 4 hours, one of these pumps starts up, that's running right now. This is bringing it back to the beginning of the headworks there, back to the filters to recirculate the bacteria back through over there. So that process is going on constantly through there. And right now, as you're looking, it's about a little over 3.5 million gallons going through for right now. As you look at the gauges, you can see this is going through 671 gallons a minute for right now. It's going in there through this pipe over there. And that's almost 1 million gallons right there. You can see the pressure coming in. And that's the differential pressure going out there. And then there's the residual pressure, 43.54 right there, just representative. And then we can take samples on the raw, backwash samples over there that we do for analysis on each one of the 4 filters. Also in the filter room is where we have some of our treatment plant chemicals. We have potassium hydroxide, known as caustic soda, 6,000 gallon tank, 550 gallon day tank. We have a series of pumps that pumps between the 2 tanks and out to the system. On this side here is our chlorination or disinfection. Sodium hypochlorite, 12.5%. We have a 550 gallon day tank, bulk tank, an 85 gallon day tank. 2 peristaltic pumps that control the rate of flow back out into the system. Also adjacent to that room, we have 2 more chemicals. We use liquid polyphosphate that comes out of this bulk tank into this day tank, and we use that for corrosion control. That's for lead and copper control to give a coating to the pipe 50% poly, 50% orthophosphate. This is the sodium fluoride that we put into a saturator. It mixes with water on that. It's pumped out about 6% solution for about a 0.7 residual. We're pumping about 5 gallons an hour out there right now. We set our pumps from a 4 to 20 milliamp signal on that, so we're just about halfway, a little less than halfway on that there. So those are the 4 treatment plant chemicals and how we're used over there. This is our electrical control room also. That controls all, there's our motor control centers on that side. This controls all the feeds for our generators, transfer switches. Out here, this is all our main electrical feeds come into this room here. This is the aerator pump room here. It's a little loud inside, so I'll kind of describe it right here. Then you folks can take a quick look inside. There's a series of 3 aerators, 3, 2, and 1, where the water comes in the back. There's 8 stages where air is introduced to remove any volatile organic compounds. Then once it goes downstairs, and that piping you saw a little bit earlier, it sets in that clear well, and there's 3 finished water pumps. Each has a 250 horsepower motor that pumps it out the distribution system over there. So as the water comes off these filters, the chemicals other than potassium hydroxide, or KOH, is introduced, sits for 2 hours contact time into an inner and outer chamber, sits for that to get a residual, and then out to the system out there. So I'll just open this quick. You can kind of take a look. We also have a certified laboratory here in the plant that we do for total coliform E. coli, in which we have certain refrigerator units, we have autoclave units, pH, chlorine, residuals, manganese residual meters over there. And we do run, like I said, all our own samples for total coliform in the town from all our tank sites, all our representative sites, and we also split samples with a private lab too, just to verify our results over there.
I was just wanting to understand if this feeds the whole town and how much water goes through here a day. Just I think people might be interested.
Yeah, we're averaging about 3.3 to 3.4 million gallons a day, which is 3,400,000. So all the wells come into here, one common pipe. So this feeds the entire town, comes through here, 100% over there. Because many years ago we used to have chemicals in each one of the wells, Beth, but we found better to have centralized treatment so everything comes in and you eliminate that for more consistency and reliability on that. So this is called centralized treatment. All the flow unifies into a common header and is treated at a universal source, which is here.
And it's 8 wells.
8 wells, correct. 8 groundwater wells, correct.
Great, thanks. It's neat.
So do you want to talk a minute about the Hex Chrome and how this is?
Yeah, and actually, yeah, we also did some pilot testing on Hex Chrome on a biological methodology over there. Of course, our plant was getting torn down at the same time there, but the samples that we did run showed that we basically get out to zero again on the Hex Chrome on biological methodology. It was a company out of Georgia that supplied the material to us, but we noticed even on the monitoring wells, everything has been much lower. I think because the groundwater has gone up, it's come lower, but last time it was about 3 parts per billion. The limit in Massachusetts is 100 for total chromium. The only state that has a limit for hex chrome is California, which is 10, which goes into effect in 2020 for right now, so even below that for right now. But we might see some reduction here. We haven't, no one's ever really tried it with these sand filters, so we'll see if that helps out any on that there. Might be a side effect on that, we don't know, but we'll find out.
That's great.
So Bob, this is pretty state-of-the-art, and we're getting some attention to the facility?
Yes, it's kind of ironic over there. We had WPI come through last week, their civil engineering department, chemical engineering department. We had UMass Medical 2 weeks before, and New England Water Works has a conference in April at the DCU Center. So for them, there's a talk on this at the conference, and there's a bus tour from DCU Center here next April for the water professionals. Yeah, it's a hot topic because more people leaning this way. There's a lot of people that are using green sand that have been calling me and say, hey, you know, what are you doing? What are you doing up there? And stuff. They're very interested over there. And there's some new facilities now. Acton has 3 plants, but now they've decided that they're going to pilot test this. I saw the guy last week. He said, you know what? I'm going to try this. I'm going to try this now. I've been doing this microfiltration. Let me try this over there. There is one that just started up in Putnam, Connecticut, smaller. I think about a month ago over there. They're trying to do a smaller one in Middleborough, Mass. For right now. Those two actually did start before us, but we were online before them, if you can believe that or not. And this would be the second largest for manganese removal in the country. Lake Havasu is number 1. This is number 2 on there. And we did, not that we traveled there, we did talk to the people at Lake Havasu before we started building this facility over there. And they said very favorable things about that. And it's from Suez Water Technology and Solutions, and Suez is the biggest water company in the world. They've taken over GE Water about, I think, a year ago. So GE folks were also involved with this. The GE Water membrane folks were also involved in this process, along with the Suez folks. We had folks from Illinois Water that were involved in the startup over there, and the GE folks also out of Canada were also involved in this. So we have folks from around North America involved in this startup over here.
So you've seen big changes in water treatment technology in your career?
Yeah. And the funny part, we're going somewhat back to the basics over there with sustainability, if you really think about it, like organic farming and some of these other things. Now we're going back to over here, sustainability, rather than just putting chemicals in and try to precipitate stuff out and take it off site. And I said the same thing about the Hex Chrome. I said everyone uses ion exchange type of setup. I said, but what do you do with the waste? In California, they bring it back to metal plating facilities. Well, I said that's not an option here in New England over there. We can't take waste off site, so we have to be able to reuse it. So that's why we went to this other system to try that. So we have that in our back pocket, so to speak, also.
Well, Bob, we want to thank you so much for the tour.
Yeah.
We hope
My
this
pleasure.
allows Shrewsbury people to get a little bit better sense of what we've spent a lot of money on, and to try to rectify some of our issues and get us positioned for the future. And from all of us at Selectmen's Roundtable, thank you so much, and we'll see you the next time.